Hello students, welcome back to Vidhyalakshmi YouTube channel. So in the previous video, we would have discussed about types of chemical reactions, and that too we specifically started about namely 4 chemical reactions we have discussed so far. One by one I will just make you a recall. First one is combination reaction, and then we discussed about decomposition reaction, and then displacement, and then double displacement. The left out type of reaction in the first chapter is redox reaction. So in this video specifically we are going to learn in detail what is redox reaction, and few terms are involved in that, and we are going to learn that also. So first, what we are going to learn: what is redox reaction, what is oxidation and reduction, and then what is oxidizing and reducing agents, and then at the last we will be studying about what is corrosion and rancidity. You might be thinking, what is they related with corrosion and rancidity with redox reaction? Once you come across all these things, you will come to know what is why this term has been related here. Okay, so let us get into the video. First, let us know what is redox. Redox is nothing but it is a chemical reaction that involves both oxidation as well as reduction reaction. So that is why it is termed as redox, and this redox term comes from the combination of two words, reduction and oxidation, and red from reduction and OX from oxidation. Together it is termed as redox. So this is how the term redox has been framed. So you just keep in mind that redox reaction is nothing but it is combination of both oxidation as well as reduction reaction. So if in a reaction both the oxidation and reduction is occurring, then we call that reaction as redox reaction. Okay. Next, what is oxidation? So we have known redox is nothing but a combination of oxidation and reduction. So we have to learn what is oxidation first. So oxidation is nothing but, so just a simple term, addition of oxygen to a substance. It is called as oxidation reaction. You just follow the lines here. Oxidation can be defined as addition of oxygen or an electronegative element to a substance. This is in terms with addition of oxygen. There is one more term where we can define oxidation reaction. It is nothing but removal of hydrogen. Is that clear? So either if it is addition of oxygen or removal of hydrogen, then we can call that reaction as oxidation reaction. So this is related with addition or removal of oxygen or hydrogen. There is one more way that we can define oxidation. That is nothing but in terms of electron, oxidation is defined as loss of electrons. Okay, in terms of oxygen and hydrogen, oxidation is nothing but addition of oxygen or removal of hydrogen. This is in terms of addition and removal of oxygen or hydrogen. In terms of electron, oxidation is defined as loss of electrons. So in this level you will be studying with the terms of addition or removal of hydrogen or oxygen, but in terms of electrons you will not be studying at this level. When you move to the higher grade, you will be studying specifically about this. So I hope now you will be clear with what is oxidation. I will just recap again. It is nothing but addition of oxygen, or it is not a compulsion that both the things must happen. Either one, if it happens also, we can call it as oxidation. Addition of oxygen or removal of hydrogen, or we can also call it as loss of electrons. It is also called as oxidation reaction. If you see this example, copper is reacting with oxygen gas. When we heat it, it forms a product as copper 2 oxide. We call this as copper 2 oxide, since the valency of copper here is 2. So if you see here, oxygen is added to a substance. So this reaction is called as what? Oxidation reaction. Fine. Next, we will see on what is reduction reaction. If you have understood what is oxidation, reduction will be more easy. It is just opposite to the oxidation reaction. You just see the lines here. Reduction can be defined as addition of hydrogen. There it was addition of oxygen, whereas here it is addition of hydrogen. Next, or a electropositive element to a substance, or removal of oxygen. We call it as reduction reaction. It is directly opposite to oxidation. There it was addition of oxygen, removal of hydrogen. Here it is addition of hydrogen or removal of oxygen. So this is in terms related with either addition or removal of hydrogen and oxygen. There we discussed with the electrons, right? So here also reduction can be defined as gain of electrons. There it was loss of electrons, whereas here it is gain of electrons. Okay, if you just compare and see, both will be directly opposite to each other. We just see an example here. Hydrogen is added to fluorine. So addition of hydrogen, what do we call it as? Reduction reaction. So when hydrogen is added to fluorine, it produces hydrogen fluoride. So it is an example for reduction reaction. So we have learned what is oxidation and what is reduction. Now we are going to learn what is redox reaction, how it is going to be. We are going to see in the next slide. And before that, we have to concentrate on what is oxidizing and reducing agent. Once if you are clear with this, I will move on to the example of redox reaction. First, oxidizing agent. An oxidizing agent is nothing but it is a substance which oxidizes the other substance. Okay, it will oxidize the other substance, but itself will get reduced. I know that with the definitions, you people will not be that much clear. I'll just define you the terms. Once we discuss with the examples, you will be very clear. Okay, oxidizing agent is nothing but it is a substance which oxidizes the other substance, but itself will get reduced. So this is oxidizing agent. But reducing agent will be opposite to the oxidizing. You just see here, and reducing agent is a substance which reduces the other substance. Here it is oxidizes the other substance, here reduces the other substance, but itself gets oxidized. So it is directly opposite to each other. Okay. So in simple words, oxidizing agent, it causes oxidation, and reducing agent causes reduction. This is just a definition. We will see with the example now. One example has been given here. If you see here, copper oxide is reacting with hydrogen to produce copper and water. We are going to see whether this is a redox reaction. If it is a redox, we have to find whether it is oxidation and reduction both are involved or not. You just see here, hydrogen in the reactant side. If we trace the hydrogen in the product side, see the difference between the substances here. Here it is hydrogen alone, whereas here hydrogen is attached with oxygen. So what has happened? Oxygen has been added to hydrogen. So this reaction we call it as oxidation reaction. If you see copper oxide, in the reactant side, it is combined with copper is combined with oxygen, whereas if you see in the product side, oxygen has been removed. So removal of oxygen, we call it as reduction reaction. I hope you can correlate with the definitions whatever we have studied, right? So oxidation is nothing but addition of oxygen, or removal of hydrogen also there, but in this reaction addition is happening. The same way for reduction, it is either addition of hydrogen or removal of oxygen, whereas here oxygen is removed. So this is reduction reaction. Now we have learned two terms newly, right? Oxidizing agent and reducing agent. What was the definition for oxidizing agent? The substances which oxidizes the other reactant, but itself will get reduced. So if you see according with that definition, you just consider this reactant copper oxide. What is it doing? This copper oxide donates this oxygen atom to hydrogen, right? That is why water has been formed there, right? So it oxidizes the other substances. Can you understand here? This copper oxide oxidizes the other substance, right? This is oxidizing, but itself get reduced. You just see copper oxide itself is getting reduced. So we can call copper oxide as a oxidizing agent. Am I right? So if this is going to be the oxidizing agent, what is hydrogen going to be? Yes, it is going to be reducing agent. Only if both the agents are involved in a reaction, then that reaction will be called as redox reaction. If only oxidizing agent or only if reducing agent is there, then it is not going to be redox. It is going to be either oxidation or either reduction separately. But if it is a redox, both the terms will be involved definitely. Okay, I'll just give a recap again. This copper oxide is donating its oxygen atom to hydrogen. So it is oxidizing the other reactant or the other substance, but itself is getting reduced. This is in accordance with oxidizing agent. If you see reducing agent, What is the definition of reducing agent that we learned? It reduces the other reactant, but itself gets oxidized. So in that manner, if you see hydrogen, it gets oxygen from the copper oxide so that it reduces the other substance, but itself gets oxidized. So this is about finding the oxidizing agent and reducing agent. These kind of questions will be appearing in your exams. The questions how it can appear is, they will be asking which substance is oxidized, which substance is reduced, which is oxidation, which is reduction. In this case, when this kind of questions will be appearing from this topic. Okay. One more thing, if the question is asked, you just see copper oxide, how we have to mention is copper oxide is reduced to copper. This is how we have to mention. If it was a descriptive type, you should have followed this. Since term 1 is going to be objective type, so don't worry about it, but you just learn these things also. Copper oxide is reduced to copper. In the same way, hydrogen is oxidized to water. So this is how we have to mention whether which is oxidized and which is reduced. So we will have such kind of examples much more now. I will move to the next slide. Next, zinc oxide reacts with carbon. It gives zinc plus carbon monoxide. Okay. So before this, I will just make you clear one thing. We discussed with addition of oxygen, addition of removal of hydrogen, oxygen, everything. But in terms of electrons also we have learned. There is a short term that we can use to easily remember. The term is Lioger. Okay, this is nothing but L represents loss of electron. This is nothing but oxidation. This is just a term to remember the oxidation and reduction process. Loss of electron, see LEO, loss of electron, oxidation. By now you would have guessed right. Gain of electron is called as reduction. So you can just keep this in mind, Lioger. If you know this, you can easily find whether it is oxidation or reduction. But in this 10th standard level, we are not going to discuss with the loss and gain of electron. We are going to discuss about addition or removal of oxygen and hydrogen only. Okay. So in this example, zinc oxide reacting with carbon, it tends to form zinc plus carbon monoxide. We call that as carbon monoxide. So now first find which is oxidation and which is reduction. You just see this reactant zinc oxide, you just trace this zinc in the product side. This is how we have to do. We have to consider one reactant and trace it to the product side and check what has happened, what difference we can find. So if you see here, zinc is attached with oxygen atom, but if you see in the product side, there is no oxygen here. So what has happened? Oxygen has been removed. So if there is removal of oxygen, what do we call it as? We call it as reduction. Okay, so this is going to be the reduction here. If this is going to be the reduction, which is going to be the oxidation? Obviously, yes. Carbon, in the reactant side, it is in independent state. If you see in the product side, it is attached with oxygen. So what difference can we find? Oxygen has been added. So we can call it as oxidation reaction. So since oxidation, reduction both are occurring here, this reaction can also be called as what? Redox reaction. Okay. So now we have found out what is oxidation, which is reduction. How can we represent in sentences? We just try it. Zinc oxide is oxidized or reduced? Yes, it is reduced. Zinc oxide is reduced to zinc. The same way, copper is oxidized to, carbon is oxidized to carbon monoxide. This is how we have to represent in sentences. So if you have found this, next step is to find which is oxidizing agent and which is reducing agent. Okay. By now you would have guessed, I hope. Zinc oxide, it is undergoing reduction, carbon is undergoing oxidation. So it is almost similar to the previous example which we have seen. Here, zinc gives this oxygen atom to carbon. So what does it do? It oxidizes the other reactant, but itself get reduced. So this is going to be what? Oxidizing agent. So if zinc oxide is going to be the oxidizing agent, obviously carbon is going to be the reducing agent. If you find it difficult to find which is oxidizing agent and which is reducing agent, a short method what you can learn is, the substance which is undergoing reduction, we can call it as oxidizing. Just you consider it opposite manner. The substance which is undergoing reduction, we can consider it as oxidizing agent. In the same way, the substance which is undergoing oxidation, we are going to term it as reducing agent. This is just a short method. If you find difficult, you can mention in this way, or else if you go according to the definition, it will be more clear to find which is oxidizing and which is reducing agent. Okay. So I think this example will also be clear. We will discuss few more examples also in this video. Next, manganese oxide reacts with hydrochloric acid and it tends to form manganese chloride plus water molecule plus chlorine. So what is the first step? You have to find which is oxidation and which is reduction. So you just start, always you have to consider from the reactant side. From reactant side, we have to move on to the product side. Okay. So manganese oxide, you consider manganese, this substance, you trace it to the product side and see what can you observe here. What difference are you able to observe? Manganese is attached with oxygen, whereas there it is attached with chlorine. So what has happened? Oxygen atom has been removed from manganese. So removal of oxygen, we call it as reduction. Right. The same way, here hydrogen is attached with chlorine, but you trace the same hydrogen here. What difference can you see? Here hydrogen is with chlorine, whereas here hydrogen is with oxygen. So oxygen is added. So what can we say? Oxidation reaction. So since both oxidation and reduction is happening here, this is going to be what reaction? Redox reaction. So we have to mention it in sentences, right? MnO2 is reduced to manganese chloride. The same way, hydrochloric acid is oxidized to water. So this is how we have to mention it in the form of sentences. Since second step we have done. Third, we have to find which is oxidizing agent and which is reducing agent. So as I told you earlier, the substance which is undergoing reduction, we can call it as oxidizing agent. So what is oxidizing agent here? It is going to be manganese oxide. And which is going to be reducing, obviously. If this is going to be oxidizing, hydrochloric acid is going to be reducing agent. So reducing agent is HCl. So this is how the questions may be asked. They will be asking whether which is oxidized, which is reduced, which is oxidizing agent, which is reducing agent. So if you understand this concept, whatever the equation, whatever the questions may be, definitely you can solve it out. Okay. Next. One more example has been included. We'll just discuss and then we'll move on to the corrosion and transferability topics. Okay. In this example, iron oxide reacting with hydrogen gas and it tends to form iron plus water. So you just start doing there. Iron, you just trace it on both the sides. In the reactant side it is with oxygen, whereas in the product side it is in independent state. It is not combined with any other atom. So what has happened? Oxygen has been removed. So it is going to be called as reduction reaction. The same way, hydrogen, it is independent, whereas if you see in the product side, it is attached with oxygen. So it is going to be what reaction? Oxidation. Since oxygen is added, Addition of oxygen, we call it as oxidation. So it is oxidation reaction. So it is going to be redox. Next, write it in sentences, which is oxidized and which is reduced. Here, Fe3O4 is is reduced to Fe, and hydrogen is oxidized to water. So this is the second step. Third step, we have to find which is oxidizing agent and which is reducing agent. So the substance which undergoes reduction, we are going to call it as oxidizing agent. So Fe3O4 is going to be the oxidizing agent. So if that is going to be the oxidizing agent, hydrogen is going to be reducing agent. So that's it. So I hope you will be very clear with finding which is oxidized, which is reduced, which is oxidizing and reducing agent. So with this, we'll stop this part. We'll move on to the next topic, corrosion and rancidity. By the time whenever you hear the word corrosion, immediately what comes to your mind? Rusting of iron, right? But it is not actually only rusting. Corrosion and rusting, there are a minute difference between them. That is what we are going to learn in this video. These are the examples that immediately it will get struck off whenever you get the word corrosion, right? So this is nothing but the rusting of iron, the same way metals are being corroded. Okay, we'll move on to the actual part. What is corrosion? It is nothing but, you would have seen some materials which is made up of metals. If it is exposed to the outer atmosphere for a few days or a few months, its nature or the color or the surface, you would have seen it would become dull. From its shining nature, it will become dull. That process only we call it as corrosion. But how does it happen? That is what we are going to learn. We just follow the lines. You must have observed that iron particles, mainly iron particles, are shiny when it is new and it is being prepared. But it gets coated with a reddish brown powder. Just note this word. It coats with a reddish brown powder when it is left for some time to the outer atmosphere. This process only we call it as what? Rusting of iron. I'll just write the equation. Iron, when it is reacting with moisture. What is moisture? The wet, like water vapors which is present in the air, and it reacts with oxygen as well in the atmosphere. So if it is reacting with moisture as well as oxygen which is present in the air, it tends to form a product called as Fe2O3, sorry. Fe2O3 dot XH2O. What does this X represent? It is nothing but the number of water molecules which is going to be involved. Since it is not a fixed value, we are mentioning it with a variable here. So this product is what we call it as rust, the formation of iron oxide with water molecules. So this we call it as, specifically the water molecules which is attached to a compound, we call it as water of crystallization, which we are going to learn in detail in the second chapter. Water of crystallization. Okay, so this is the process which is happening in the rusting of iron. The same way you would have seen copper, silver, these metals are also getting, like in day to day, it loses its shining nature. What does it mean? What is the process happening? We'll see in the next slide. Okay. When a metal is attacked by substances around it such as moisture, acids, etc. It is not only moisture. There are acids which are corrosive in, you would have heard this word, corrosive in nature. Okay. So these kind of substances, moisture, acids, it is said to corrode, and this process is what we call it as corrosion. So by now you would have guessed what is corrosion. Corrosion is generally for all the metals. If it loses its physical nature, if it loses its color, then we call it as corrosion. Rusting is specifically meant only for iron particles. Okay. So the black coating on silver, you would have seen silver ornaments and all. If it is exposed, you would get a kind of black colored coating on the layer of the silver substances. That is called as corrosion. The same way, a green colored coating on copper, These are all the few examples of corrosion. What are the causes of corrosion? Corrosion, it is not helpful at all. It is in some way it is giving us a damage to the substances. If you see, maximum all the car bodies, bridges, iron railings, ships, all these objects, it is made up of certain kind of metals. So these metals, almost it is exposed to atmosphere all the time. So if it tends to react with moisture, all the gases which is present in air, and obviously it loses its color and the physical nature. So that is what we call it as corrosion actually. And due to this corrosion, it gives us a various problems. It can make accidents also, and it gives us more economical problem, and you have to spend more amount of money to replace it each and every year. So these are all the causes of corrosion. So we are knowing that corrosion is causing us some sort of damages. There must be a way to prevent it, right? So that is what we are going to see now. Ways to prevent corrosion. These are the few ways which is available to prevent corrosion. One of those is applying paint. What is going to happen if we apply paint over this object? For example, if you take an iron article or a copper or a silver, whatever it may be, if we apply a layer of paint, it prevents that metal from getting oxidized. It means that it will not allow oxygen to react to that substance directly. So that layer of paint is going to prevent that object from being oxidized. Okay, now I think you can coincide this oxidation to this corrosion property, right? Corrosion is nothing but a kind of oxidation, so that the metals are losing its nature. One is by applying paint, we can prevent oxidation. Next, applying grease or oil. This is also forms a separate layer and it is going to prevent. Galvanization, it is nothing but applying a layer of zinc metal. If we apply a layer of zinc to a specific metals, it prevents that metal from being oxidized, so that we can extend the days or extend the lifetime of the material. That is why this process is applied. And then tinning, it is also nothing but applying a layer of tin. And then alloying, you know what is an alloy. Alloy is nothing but a mixture of metals or non-metals. So it is going to enhance the properties. So it is also a kind of way which can prevent these metals from being oxidized. So this is about corrosion. I think you can relate this with oxidation and reduction, right? Next is going to be rancidity. You might be thinking, what is rancidity? Why it is being related here? It is also related to an oxidation reaction. If you see this image, I hope you can understand. You can see this chips, but this chips is being oxidized already. You can see here, fresh oil, rancid oil, right? I think you would have guessed by now itself. Rancidity is nothing but it is a general term which is used to refer the spoilage of food. The food gets spoiled when? If it is being oxidized, if it reacts with the outer atmosphere. That is why few food items and all, if we keep it exposed to the outer atmosphere for a long time, obviously it is unfit to eat, right? It gets oxidized, and that process is what we call it as rancidity, and that state we call it as rancid state. Okay, food turns rancid and the fats and oils within them get oxidized. This is the most important term. It gets oxidized and the taste and the smell of the food changes. You would have got some kind of pungent smell which is unfit to eat and all you would have observed in your lifetime. That is what we call it as rancidity. Okay. For example, oil becomes rancid due to decomposition of fats it contains, or sometimes milk also becomes rancid due to not eating it in a humid atmosphere. So these are all the few examples of rancidity. So we know rancidity is happening, it will happen, but there must be a way to prevent it, right? So that we are going to discuss now. Ways to prevent rancidity. One of the ways is adding antioxidants. You would have heard the word antacid, which cures the acidity in our stomach. The same way, antioxidant is nothing but it prevents the food items from being oxidized. That is what we call it as antioxidant. Antioxidant means it reacts opposite to it. It prevents it from being oxidized. So this is one of the method. Then another method is keeping food items in a closed container, a closed kind of boxes, so that it will not allow oxygen to enter into the container, and so we can prevent it from being oxidized. Another method is refrigerating the food, which also helps us in reducing the rancidity. And the last is replacing oxygen in the containers with another gas. You would have seen, no, in the chips packets and then in the soft drinks and all, there is a kind of gases which is being flushed inside it. One is, it is used as a preservative, and the other one is to prevent it from being oxidized, right? So this is all about the redox reaction. So in this video, you would have come to know what is redox, what are the terms involved in the redox, for example, oxidation, reduction, and we have seen some examples how to find which is oxidation, which is reduction, and most importantly, oxidizing agent, reducing agent, and then at the last, we have discussed about corrosion and rancidity. So I hope this video was helpful to you. So in the upcoming video, we are going to have some practice on MCQ type question, that is objective type questions, assertion, reason, case study on the first chapter. Okay, so till then you just prepare well. We'll see in the next video, students. Thank you. Bye.